Hi friends, welcome back. Now let's get to our next session. We just look into what a page table is and its details, its structure and so on. So page table basically is a data structure used by the operating systems to map the virtual pages to the physical frames. So the actual process is divided into pages, and these pages are actually dumped onto the physical memory in the form of frames. So these pages are virtually in order, first page, second page, third page and so on, but on the physical memory we may not get the locations on the consecutive pages or consecutive frames, so it may be wherever available a frame is mapped for any page. So this data structure will help us to map the virtual pages of a process to the physical frames in the memory. And the virtual memory address is usually given by the page number plus the offset. So if we are talking about a particular code in the process, a particular instruction in the code, then that particular instruction may belong to some page, and that pages are numbered, and these numbers are called the page number. So the page number will be used as an index to which page we are actually referring to, and then inside that page we have a list of instructions, a list of data. So which particular instruction or which particular data we are referring to is given by the offset. So any virtual memory address can be computed using the page number plus the offset inside the page number. And this page number, as just discussed, is used as an index into the page table, and the page table entry tells which frame this particular page is stored in. So the page 0 stored in which frame, page 1 stored in which frame, and so on, and that is given by the entry done in that page table. So that tells about which frame is used to store that particular page. Now looking at this figure, we can understand what the whole thing is all about. So the CPU will give out the virtual memory address of the data or the location where it wants to go or anything like that. So this virtual memory address consists of two things, P and D. That is, P is the page number and D is the offset. So this P is an index to the into the page table. So looking at P, that is after P lines away from the beginning in the page table, we have a page table entry that tells which frame our page is in the main memory. So the P represents the index in the page table, and at that index we find the frame number. So that frame number F comes here, and to that the offset is added, and that gives us the actual memory address. So that way the page table will help us in mapping the virtual address into the physical address. Now looking at the page table, there are basically two types of structures. We have two structures for page table. One is hierarchical paging and other one is the hash page tables. So let's look at them one by one. So hierarchical paging is instead of having the whole system into one page table, all the frames you put on one page table, we can arrange them in different layers. So for example, in books, if you want to say, then one option is keep page number for the whole book system. So page 1 to the last page for the whole book is one option. That is one level of paging. Another level of paging would be you just divide the book into chapters, and then in the contents page only say the chapter 1, chapter 2, chapter 3, and once you go into chapter, then you can have another page table there which talks about which content is there in which table. That is, one content page is there for every chapter, or in other words, if we have a very huge size, then instead of putting all the information on one big book, we can divide that book into different volumes: volume 1, volume 2, volume 3, volume 4, and so on. And then each volume will consist of its own page table, that is the contents table. Then in turn, you can have chapters inside each volume, and each chapter may be given page numbers from 1 onwards, and so on. So that way you can think of a multi-layer paging system. So here this is talking about a 2-layer paging system where we have one outer page table, and each entry into this will represent one contents page, and that content page will in turn refer to various frames in the main memory. So the first level of page table talks about, out of n page tables in the second level, which page table to use, and then the second level page tables talks about the mapping to the frames. So first level doesn't map to the frames, it maps to another page table, the another page table maps to the frames. So if this is not sufficient, then we can go for one more layer. So the third layer will talk about many page tables at second level. Each page table in the second level will talk of many page tables in the first level, and the page table in the first level will refer to various frames in the main memory. So that's how it can be done. Then this way you can understand it. So this is a 2-level hierarchy. So we have index for outer page P1, then index for the second level page table. So P1 is an index of this page table. Inside that we refer to another page table, and P2 talks about index of that, and there we write where exactly the frame is, and inside that frame how much away our actual memory is located is given by this displacement. Want to understand better? So let's take another example. The CPU will provide this address, so a 32-bit virtual address may say, so which says that 10, 10, 12. So this 10 talks about the index of the first page. So the CPU will give this, so index of the first page, so it goes to the, in the first table goes to the 10th index, and that will say which page table in the second level should be used, and that page table's starting address is shown here, and to that the index of the second page table is added, and there we come to the 10th location again here, and this 10th location will say where exactly the frame is starting in the main memory, and to that the offset is added, and that will give exact location in the main memory. So we have a physical memory which has got frames, and we have a virtual memory which talks about the process. So this is made up of pages, and virtual memory is made up of frames, and the paging table is trying to map the virtual pages of the process to the physical frames in the main memory. So that way we can easily locate any location in the main memory through paging table, one level paging table, or 2 level or 3 level. So in general, a hierarchy of page tables is used, hierarchy levels are used, so a very complicated system can be easily accomplished through this. So that's about the hierarchical paging. Thank you.